virtual machine is server level virtualization, whereas containers are operating system level virtualization. So the kernel of the host operating system serves the need of running different functions of an app separated into containers. Each container, for that matter, runs isolated tasks. Means that each container is totally isolated process-wise from another container, although all of them share the same host operating system. Again, this is totally contrary to a virtual machine where we have multiple virtual machines, each of them having dependency on their own guest operating system. Now, each container runs isolated tasks which can not harm the host machine nor come in conflict with other apps running in separate containers. So again, isolation in two different levels. One is isolation from another container in that same host. Also isolation from the host operating system itself. So if we see this diagram over here, a typical container model looks like this. We have the server hardware at the bottom, and then on top of that we have the host operating system. Up to this, it's exactly same as the virtual machine model. Now on top of that, think of what is present in a virtual machine is our hypervisor. Instead, over here we have something called the containerization engine. This is basically a container daemon process that actually runs and makes container creation possible. So this is the container engine. It's again a very light engine that runs on top of the host operating system. And on top of that, we have multiple containers. Okay, and if you see here, each container is not a virtual machine in the sense that they don't have any operating system attached to them separately. They are all having the host operating system shared between them, and that's the virtualization we are talking about. So each container is nothing but a small package. Okay, is nothing but a small package of what? Of dependencies and the application which is going to run in that container. So three containers over here, container 1, container 2, container 3, having three different apps, and each of them contain the dependencies for that app. Now you can take this and extend this to a model where we have again a development environment, a QA environment, and a production environment, and you may have a single app but multiple such dependencies for these three environments. So you can create three different containers of the same app and then package all the dependencies, all the separate dependencies. So for example, if we take as like we have an Office dependency, Microsoft Office dependency for our app. However, in the production environment, we have a Microsoft Excel version, a lower version running, which means that the container 3, let's say, which is for the production, will have that particular dependency of that particular version of Excel packaged into it, whereas the same app will have a different container with a different dependency attached to it for the QA environment for that matter, and the same for the development matter. So, but that also means that you can never have a scenario where somebody says that my application runs in my environment, or it runs in the development environment but doesn't run in the QA environment. It just can't happen, because all the dependencies are actually attached to the container itself. And so when you install the container, all those dependencies go with it. And if you have a sound plan with you, then upon deployment, you should never have these kind of issues. Now, how do containers work if we just go a bit more detail? When working inside a container, we create a template of an environment we need. So basically, we are talking about images here. So remember, we talked about an image is nothing but a version of an operating system, but here we take that, we extend that to a broader level where we say that an image is nothing but a template, or a template is nothing but image, and we create a template of our own dependencies of an application, and we publish that template, and that particular thing is called an image. And once that image is being created, a container can be actually created out from that image. Okay. Now, the container essentially runs a snapshot of the system at a particular time, providing consistency in the behavior of an app. The container shares the host's kernel to run all the individual apps within the container, as I said. So it just shares the host's kernel, okay, the host kernel, to run all the individual apps within the container. Now, my particular image shows 3 different containers for 3 different app versions, but it may have all the apps inside one container also. The only elements that each container require are binaries, libraries, and other runtime components. Now, let's go to the benefits over here. Now, containers can be as small as 10 MB. Why? Because there's almost nothing inside a container. There is no guest operating system. And this makes the containers remarkably lightweight and fast to launch, as opposed to deploying virtual machines where the entire operating system needs to be deployed. Now, because of the size, we can quickly scale in and scale out containers and add identical containers. For a virtual machine, this is not easy. It takes a lot of time for a virtual machine to spin up. And well, the cons of a container model are very few. So a container uses the kernel of the host operating system and has operating system dependencies, of course. Therefore, containers can differ from the underlying OS by only dependency but not type. What that means is that in a typical container model, you can't have a heterogeneous environment, which means that if you deploy 2 containers on top of a server which is having a host operating system of Windows, then both these containers will eventually have a Windows operating system because they don't have their own version. They just virtualizing the host operating system. Containers still do not offer the same security and stability that virtual machines can. So containers are, mind you, from an isolation point of view or a security point of view, a little bit lower than virtual machines. Why? Because again, they share this host's kernel. So definitely you get some benefits. Obviously, you'll have to pay for them, right?